All right, 6-6, solving radical equations. And when we talk about radical equations, we're talking about anything that has a radical in it. So things that have radicals in them would be square roots or cube roots or anything like that. So anytime you see a function with that in it, that's what we're talking about. To solve radical equations, the very first step that you want to take is you need to isolate the radical. All right? That means get the radical by itself. So peel everything away from that side of the function, and then if you raise each side to the power of the radical, I'll show you that in just a minute, and then you solve whatever's left in the equation. And I know this is stuff that some of us have done before. At least we certainly have the ability to do. For some of us, this is going to seem fairly new, and that's okay. So if I take a look at this one, I have the square root of x plus 6 equals 3. Well, if I square both sides, I get 9 on the right, but on the left, I have x plus 6. And then I minus 6 on both sides, I get x equals 3. And so the solution is 3. I can put that back into the original. 3 plus 6. What's the square root of 3 plus 6? Or the square root of 9? 3. That works. Great. You guys go ahead and do checkpoint number 1. Okay. Hopefully you gave that a good shot. Minus 1 on both sides here. And now we have the cube root of x minus 5 equals negative 2. I take both sides to the third power, and negative 2 to the third power is negative 8. So I have x minus 5 equals negative 8. Add 5, x equals negative 3. And in all of these, you should always check your answer. And there's a real reason why we should check our answer. So if I go back into here and I find the cube root of negative 3 minus 5, or negative 8, plus 1, well, the cube root of negative 8 is negative 2, plus 1, that equals negative 1. So that checks out. That's good. But the reason why is there's going to be a thing called extraneous solutions coming up here in a little bit. So make sure that you're ready to check all of your work, because that will be important. Let's take a look at this one here. We have 3x plus 4 to the 2/3 power. Well, I'm going to take both sides to the 3/2 power. And if I take both sides to the 3/2 power, that will eliminate this right here. So I'll have 3x plus 4 equals 16 to the 3/2 power. Now you may remember what we did when we had those kind of functions earlier in the trimester. I would do 16 to the 1/2 power to start, and I'd get that answer, and then I'd cube it. So 16 to the 1/2 is 4. 4 cubed is 64. So now I have 3x plus 4 equals 64 minus 4. 3x equals 60. Divide by 3, x equals 20. Don't forget, check your work. So put 20 into your original. Does 3 times 20 plus 4 to the 2/3 power work? Well, I get 64 to the 1/3 squared. And 64 to the 1/3 is 4 squared. That's 16. That works out. Great. All right. Let's take a look at example 3 here. On example 3, I have to isolate right away. Let's switch colors to something a little more soothing to our eye here. If we isolate right here, we get, oh, I'm on highlighter. Okay, let's go to pencil. And let's go to pencil in blue. Let's stick a line in blue. All right. So let's try this again. Here, 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 here. There we go. So when we look at this thing, we have x minus 2 equals the square root of x plus 10. If I square both of these sides, it ends up getting real messy. It ends up being x minus 2 times x minus 2. And on the right side, I got x plus 10. Well, x minus 2 times x minus 2 is going to require some FOILing. So it's going to be first x squared minus 2x plus 4. Or x squared minus 4x plus 4 equals x plus 10. Well, if I subtract x on both sides, I get x squared minus 5x. And if I subtract 10, I get negative 6 equals 0. So I'll write that right here. X squared minus 5x minus 6 equals 0. At this point, you could use the quadratic formula, or you could factor it, whatever you wanted to do to try to get yourself down to these answers. I'm going to probably just factor because that's what they're asking me to do in the notes here. Probably would do quadratic formula usually, though. X and x, what numbers multiply to be 6 and add up to be 5? Well, that would be a negative 6 and a positive 1. So my answers are 6 or negative 1, because x minus 6 equals 0 and x plus 1 equals 0. So 6 and negative 1. When I check my answers, I'm going to put the 6 over here and the negative 1 over here. 6 minus 2 is 4. 6 plus 10 is 16, and the square root of 16 equals 4. That works. That's great. But this one over here, when I do negative 1 minus 2, I get negative 3. Well, the square root of this is not going to be negative 3. The square root of negative 1 plus 10, 9, is not going to be 3. So this does not check out. This is a bad answer. Bad answer. Okay? When we have a bad answer, we call that answer extraneous. So the only solution is 6. The apparent solution, negative 1, is extraneous. And that will cost you points on the test if you write down the extraneous solution. Let's take a look at example 4. It's a long mamma jamma. In fact, it doesn't even fit on the whole page. Let's see if we can maybe reduce what size we're looking at here to make it fit on the whole page. Let's do, alright, that's just going to be too small. Let's try this. Let's try 65%. Let's see if that fits. That's pretty good. Okay, so there's a lot of stuff going on here, and if you could do this, you could do just about anything in math. In fact, it's great that this is the last lesson of our first trimester together, because this is the monster of all monsters. So stick with me. I will explain it the best I can. Our first step here is going to be to square each side, and so if I square the right side, 10 minus 3x, not so bad. However, if I square the left side, I get x plus 6 square root plus 2 times x plus 6 square root plus 2. And that's one of those monster FOIL problems. So when I do first, I get x plus 6 square root squared. So that's just going to be x plus 6. All right. When I do the outsides, I get 2 times the square root of x plus 6. And when I do the insides, I get 2 plus the square root of 6. Or 2 times x plus the square root of x plus 6. And then I end up with a 4 at the end. Okay. If I combine these, I get 4 times the square root of x plus 6. And if I add the 4 over here to the 6, I get 10. So I end up with x plus 10 plus 4 square roots of x plus 6. All right. All of that stuff. That's a 4. And it equals 10 minus 3x. Well, again, I'm trying to isolate the square root. I'm still trying to isolate this. So when I put all that on this line right here, if I can make it not look so sloppy, x plus 10 plus 4, x plus 6, and 10 minus 3x right here. If I subtract 10 on each side, the 10's go away. If I subtract x, I get negative 4x. And so I have 4 times x plus 6 right here. If I divide by 4, I get the square root of x plus 6 equals negative x. Now I have isolated the square root again, so I'm going to square both sides. I'm going to get x plus 6 equals the negative x squared, even the negative is squared, equals x squared. And so I get 0 on one side. I end up with 0 equals x squared minus x minus 6. And all I did is I subtracted the x and the 6 from both sides. Now I can factor it or use a quadratic formula, whatever way I want to do it, to come up with my two answers. In the quadratic formula, 3 and 2 look like good candidates that add up to 1. So I'm going to get x minus 3 and x plus 2 in there, x minus 3 and x plus 2. That's so much better. And therefore my answers are 3 and negative 2. All right, let's check 3 first, and we'll check negative 2 second in my original. So 3 plus 6, the square root of 3 plus 6 is the square root of 9 plus 2. Does that equal the square root of 10 minus 9? 10 minus 3 times 3 is 9. So 10 minus 9, that's the square root of 1. Does 3 plus 2, which is 5, equal 1? No. Let's try negative 2. Negative 2 plus 6 is 4. The square root of 4 plus 2, well, 2 plus 2 is 4. And on the right side, I got negative 2. 10 minus 3 times negative 2 would be 10 plus 6, which is 16. Does the square root of 16 equal 4? Yes. So I know some of you guys are thinking, oh, well, the extraneous is always the negative. Not the case. In this one, our correct answer is negative 2. And the apparent solution, 3, was extraneous. Excellent. Wow, that's a long one. That's a lot of work, but I think logically, if you stopped right now and rewound it, went back to the beginning, you might be able to work your way through that. Let's take a look at the next page here. And this is it. This is your checkpoint. Go ahead and pause and solve those and see how you do. On number 2, checkpoint number 2 here, you should have come up with 8 for a solution. Checkpoint number 3, 1, and checkpoint number 4, you should have got 4 for a solution. So I hope you got those. If you didn't get those, let's take just a second and talk about it. Go ahead and pause it, work on them again, see if you can get these, and then we'll take a minute and just see what we got here. All right. Just checking our time, see what time we had left. If we add 21 to both sides here, we get a negative 32. Negative 2x to the 4/3. And remember, we're trying to isolate right here. Isolate that thing. So I'm going to divide by negative 2, and now I get x to the 4/3 equals 16. If I take both sides to the 3/4 power, well, 16, the 4th root of 16 is 2, and 2 cubed is 8. On this next one, if I square both sides, if I take x plus 2 and I square it, I get x plus 2 times x plus 2, which ends up being x squared plus 4x plus 4, and that equals 2x plus 7. If I subtract 2x, then I get x squared plus 2x, and then I subtract 7, I get negative 3. And what you would do is find your two solutions, check them, one of them works, one doesn't. Obviously in this situation, one works, your other answer didn't. And number 4 is just like that last example. You'll end up with two answers, one of them will work, one of them won't, and move on from there. Thanks a lot, folks. Good luck.